Hi friends, this is PH2502L Laboratory Experiments by Dr. M.R. Gadhvi. Today's experiment is a parallel resonance. The aim of the experiment is to determine the frequency of a AC EMF by parallel resonance circuits by varying the capacitors. The needy apparatus are 909 transformer, inductor, capacitor, resistor, and one AC meter, AC current meter 0 to 10 or 0 to 15 milliampere range. Resonance. The resonance circuit is given over here. A parallel resonance, that means L and C are in the parallel combinations. But this LCR circuit is a parallel, that means R and L is in series and capacitor is in parallel. We will be performing this experiment in the two part. One is with R and another is without R, because in condition it's given R is equal to 0 and R is equal to 100 ohm. When I say R is equal to 100 ohm, it is a part of circuit. When I say R is equal to 0, that means it is not part of the circuit, it's a straight line. So only L and C will be the component in the circuit. Okay, let's understood what it mean by the resonance. The property of a cancellation of a reactance. I hope you are knowing that reactance, that is XL and XC. Capacitive reactance is referred as a XC. Inductive reactance is referred as a XL. So when the property of a cancellation of a reactance with inductive and capacitive reactance is in series, or cancellation of susceptance is the inverse of a reactance. रेजिस्टेंस का इन्वर्स लो तो हो जाता है कंडक्टेंस, और यूनिट उसका मोह हो जाता है, राइट, MOH. रिएक्टेंस का इन्वर्स आप लो 1 over reactance, 1 over XC or 1 over XL, then it become the susceptance. In general it is referred by either B or Y, capital Y or capital B. Inductive reactance, capacitive reactance, उसका हो जाता है susceptance, inductive susceptance, capacitive susceptance. So YC and YL. Anyway, the third one is impedance, और impedance का जब आप inverse लेते हो तो हो जाता है admittance. Okay, so again the property of a cancellation of a reactance with the inductive and capacitive reactance, that is XL and XC, is in series. अगर series में है तो उसका inductive और capacitive reactance अगर आप cancel हो रहे हैं, and the cancellation of a susceptance when inductive and capacitive reactance is in a parallel. जब ये दो parallel में होते हैं तब उसका susceptance cancellation होता है, that is a YL and YC. Okay, so with this fundamental we can proceed. Okay, one more thing, that here how basically the LCR circuit is referred as a tank circuit. It produces a range of a frequency. If inductive or capacitive range is varying, either or both is varying, then it is producing a very wide range of a frequency. Now this frequency produced by the tank circuit is the natural frequency. If this natural frequency is guided by the force frequency, that is given of the frequency given by the AC supply or the AC source, then when both frequency will matches, the resonance will occur, and this is phenomenon is known as resonance, when the natural frequency matches to the force frequency. That is another way or another approach to understand the resonance. The series resonance occurs when the arrangement of a component creates the minimum impedance. माने impedance जो पूरी सर्किट का है वो मिनिमम हो जाएगा. अगर सीरीज़ में LCR लगा हुआ है तो L और C का तो impedance कैंसिल हो जाएगा एक दूसरे का, 1/j⍵c एंड 1 ω⍵l, तो वो तो कैंसिल हो जाएगा. Reactants will be cancelled. Xc and XL will be equal and they are in the ratio, so they will cancel out. But the minimum impedance, so impedance क्या रह जाएगा, R, so the impedance will be equivalence of a R. So in this case a capacitive and inductive reactants are equal, that is Xc and XL. When a parallel resonance occurs, when the arrangement component creates the largest impedance, the impedance will be the largest. So in this case impedance will be tends to infinity, whereas in the case of series resonance it would be a minimum. Okay, so connect the circuit, how we will see the procedural part. So connect the circuit LCR in a parallel with the unknown frequency of the AC supply. In general we are knowing that when I am saying that the AC supply of your line or your electrical line which are coming in your state, and majority of in Ahmedabad that is run by the AEC and the GB, and that is having the 50 frequency, rather entire nation the India having the frequency is 50 and 230 is the AC voltage. So our expected answer of the AC supply source frequency will be near to 50 Hertz. Okay, so keep R is equal to 0 ohm, L is equal to 30 Henry, and note down the values of the current for different values of कैपेसिटर. माने कैपेसिटर बदलते जाना है और मीटर मिली एमीटर में से करंट आपको नोट करना है. वेरी सिंपल एक्सपेरिमेंट. रिपीट द एक्सपेरिमेंट फॉर द डिफरेंट वैल्यूज ऑफ आर. एक में R इज इक्वल टू 0 ओम लो और दूसरे में R इज इक्वल टू 100 ओम लो. I'm sorry. Draw the graph of I versus 1 over root C. I versus 1 over root C का ग्राफ ड्रॉ करना है. Obtain the value of capacitance for where the minimum current. I'm sorry, this should be the minimum current should be offered by that. Substitute this one in the equation. Remember this is not maximum, it's a mistake, it's a minimum. It should be minimum. So minimum value of the current. Okay, I have taken a one video link and I have drawn, I have photographed for this one. So we will be, I'm sorry, we will be again looking the okay video, how it is exactly you need to take the reading. So this is a video and just play and listen it how exactly you need to carry out the experiment.
Hi friends, this is the experiment for the parallel resonance experiment, where the circuit is connected like this. The supply, that is a transformer, is connected to meter, so I am connecting a meter. This meter is connecting via this wire as well as this wire. Thereafter the meter will go to the inductor, so I am connecting to the inductor. So this is here, for ease of. So this is inductor. Inductor to it will connect to the R. So if you look at this as R, and then this is R2 back to the source. That is why this is connections. Now C, that is a variable capacitor, and therefore the entire different value of a capacitance we have connected over here, and that would be parallel to the L and C. So this will go to the L, so it is here, okay, and R, so R is end up at this point, R, and R is end up at this point, L, L to R, and R to C. So here, so the second terminal should come the another point of R, and now the different value is appeared. You can look at the meter. This is 3.12, it is 212, it's 1.46, it's 1 O, and same way I can take all the readings and you will get a curve which is shown in the figure. The part 2 will be allow us to bypass the value of R, because in the first part R is equal to 100 ohm, in the second part R is equal to 0. So R0, that means I need to remove the R. To remove the R, the first terminal of R will be okay, but where it is connecting via R, so I will bypass this R and directly connect it to the supply. So it is a circuit like, it is the circuit like a supply to the meter, meter to the L, and L to directly the supply, and C will be parallel to the inductor. So L is started from here, so one will be at this point and its second will be at the terminal where you have connected earlier. So this will be circuit of a parallel. Again, the way of taking reading is similar. So you can look at 6.28 for first, 3.11 for second, 2.11 for three, and so on.
Okay, so with this we understand how exactly practical need to be executed. So I also find it out few important points which will be helpful to you, because in the first semester you have come across with the series resonance, and now you are coming with the parallel resonance. So what are basically difference between these two circuits, and how it would be useful in the electronics or varieties of the electronics problem, how it is exactly useful, or for a common man how I shall understand the need of a series resonance and the parallel resonance. So let's take a few of them, and the first one is series resonance is known as basically acceptor circuit, and this is a rejector circuit. That means if you have a bunch of a frequency and you want to select anyone, then you should have a series one, and when your inflow frequencies matches with your natural frequency, that will be acceptable and rest will be the block. Whereas the parallel resonance is circuit which is used for the rejecting the frequency. At the resonant, the impedance will be maximum if it is in the case of the series. At the resonant, impedance will be maximum and nearly equal to infinite, whereas here it is nearly equivalent to the resistance offered in the circuit. So if it's a LCR, then that would be maximum and equivalent to the R. तो यहाँ पे R जितना होगा और यहाँ पे infinite हो जाएगा. In the resonance, current at the resonance will be maximum, and that is given by the V by R. So maximum current value I can have in the series, that will be V upon R according to the Kirchhoff law, Ohm's law. In the parallel circuit, I am getting the current will be minimum, because you see that the impedance become the infinity. If the impedance is infinity, naturally the passing quantity of a current will be minimum, and that is mathematically you can prove it V upon L by CR. The fourth point is the series resonance circuit is basically power factor is a unity, and over here also parallel power circuit factor is again unity. The fifth point is series circuit is magnifies the voltage, whereas the parallel circuit magnifies the current. Sixth point is effective impedance is R. I think it is similar to this point, but anyway, the effective impedance is R, and therefore R is equal to V by the resonant current, and effective resistance is given by L upon CR. So inductance divided by product of capacitance and the resistance. And the last comparative point of a series, which where you having the offering impedance is very low, and over here the offering impedance is very high. So this way there are the few points. What are the observations tables? Say this is one of the past students. So you having a observation table something like this, 1 2 3 4 5 and 6 column. You will be measuring the current for given the value of a capacitor. In the video clip you have seen, there was a one capacitive bank. Many capacitors were connected in a one wooden box, and you are selecting them one by one for varieties of the values of the capacitors. So over here we do have in that board some around 11 capacitance, and their capacitance are given over here. Obviously it is in the microfarad. So when I wish to do 1 over root C, so micro, that is 10 to the power minus 6, that is in under root. So बाहर निकलेगा तो -3 डिनोमिनेटर में से प्लस में जाएगा तो +3 हो जाएगा. So ultimately whatever the value is there, you take it 1 over root C of the same value, multiply by 1000, and that would be your, here the multiply by 1000 is missing, so multiply by 1000 of the entire column should be there. Now the current of a 1 milliampere, sorry, I is a milliampere, 1 is without R, that is R is equal to 0 and R is equal to 100 ohm, and you have a to this particular range of a current. अगर पैरेलल में ध्यान से देखो तो ज़्यादा करंट से सेट होता जा रहा है, एंड रेजोनेंस अकर at some around 6, is it is the lowest one, 0.6. फिर से बढ़ने लगा करंट, सो पैराबोलिक कर्व विल बी ऑब्जर्व. अगर 100 मैंने डाला तो ओवरऑल करंट शुड डिक्रीज. आई डोंट नो व्हाई दिस इज जंप, बट अदरवाइज यहाँ पे 19 है तो 18 आ गया, 1.4 1.4 83 82 आ गया, 60 61 76 89, it is coming almost parallel. That means 100 ohms is little bit insufficient. अगर 500 ohm अगर मैंने सर्किट में डाला होता तो आपको कम वैल्यू दिखाई देती. Okay, so here it is the two graph. You can observe the lower one with the R is equal to 100, क्योंकि उसका magnitude बीच में resistance डाला, so the current passing through that is decreases, so the graph parabola curve will be lower compared to the first one. Okay, so you need to be calculate 1 over root C कितना आ रहा है 0.6, और यहाँ पे 2 1 over root C microfarad. तो how to calculate this one? So 2 pi FL is equal to 1 upon 2 pi FC, and therefore F is equal to 1 over 2 pi under root LC. And where you are finding out the 1.71 is 10 to the power plus 3 frequency capacity value. So you substitute that value, you substitute the value of 30 L is equal to 30 Henry, and you are getting the answer is 49.80. Very perfect answer. Now, on an average, it is observed in the electronical experiment that the chances of, except the component get burned, then it is the only accidental chances. Otherwise, you are getting a very good always answers, because electronic experiments are comparatively well defined, and therefore very least things are to be there to be just adjusted. Anyway, so with this I completed here. You just take it sample data and try to draw the curve by yourself, do the calculations and just check it up. What is the EMF frequency? Expected answer is a 50, so you are knowing that, and this fellow is getting a 49.80 hertz. So that way you can also calculate with this data and you can check it up. Stay home, stay safe, all the best.